Doc. Okay, so we're digital learners. Hi guys. Bye guys. There's our digital learners. Yay! And if you are a QR code person, QR code is there for you too. So this is ESP Day 1, and I am part of a partnership. My other half, he's not my husband. My husband is hyphenated. He's Poppy Chandler, and I'm Cynthia Sistek Chandler. Bill Kearney is not here. I believe he's in Japan right now. And we are the Professional Development Systems Group. Many of you have seen me throughout the years as a computer-using educator. I'm the former president of San Diego Q and have been on the board for over 30 years. Mari, thanks, Mari. I like that. And I also was one of the first people in San Diego County to provide professional development for the first Macintosh laptop at National Unified School District. So they were the first, not really one-to-one, but they gave their teachers laptops. So I've been around the county office from the early 90s, but I want to introduce you applications that you can do with your students. How many of you have used Voki before? Okay, how about Blabberize? You can make a dog or a cat or even a phenomenon, a star or the sun talk. So looking at the library of all of the different avatars and visual graphics and representations, this is the link that will take you directly to Voki, and it's creating an education site, 20 ways to integrate talking avatars in the classroom. So I have that there as a resource, and my Voki was going to say, if you could have heard it, that I'm Cynthia Sistek Chandler, hyphenated, high-tech Chandler, yeah, right. And I have been teaching online since 1999, and I taught elementary in Paso Robles, California, and was the Invention Convention coordinator for the elementary school district when I was teaching there. So I have multiple subjects in for my teaching credential, but since 1993 I've been teaching higher ed, and I teach teachers and also professionals how to integrate technology into their practice. So there's a lot more about me in my tiny URL, tinyurl.com/Cynthia Chandler. That's also I know a few of you have already started to follow me because I was taking pictures of you this morning. And one of the things I said also in my Voki is that I am really excited because I've been in the elementary classroom and now higher ed for many years, is to see a lot of the cyclical pedagogical practices come back. And that is that Common Core state standards and some of the practices in NGSS, they're always talking about all of interdisciplinary. Well, we were doing interdisciplinary many, many years ago. The 5E model I love. I love the 5E model. Engagement, explore, and explain and elaborate. There isn't any discipline that we cannot use the 5E model effectively with. Not one. And it is just a wonderful opportunity and a wonderful framework to be able to use also technology and to integrate technology into your practice. Another practice that you might have heard about is SAMR. That's substitution, augmentation, modification, and definition. Say that 5 times fast. Okay, so in the SAMR model, you're really making things a lot more usable. You might be substituting a pencil or a pencil and eraser with a word processor. Is it an online word processor? But it's always, what is the audience, who is the audience, and what is the purpose? When you use SAMR, it's not just substituting, it's using technology in a meaningful way. Also, flipped learning. You've heard a lot about flipped learning. What's the example that's up here? And that is the Khan Academy. And a little later, you're going to be using what's called a flipboard to be assessed it's a quiz, it's a friendly quiz, using a Jeopardy game board that's on a program called Flipboard. And all of these flip tools, all of these digital tools, the students will, once they're accessing these tools from curriculum that's embedded and aligned with NGSS and everything that you're teaching, they're going to use some of these tools at home to flip. So Voki and updates from the instructor. Students can use another tool called Explain Everything. I think those of you who are on iPads are using Explain Everything, and there are many other screencast programs that will help students explain and give meaningful definitions and overviews of how they are interpreting science data. I have a couple of research articles for you, what research in NGS says about technologies. And we are seeing with Oculus Rift and some of the other virtual education tools, well, I'm saying education because they really are educational, as long as we can apply and use our engineering brains. With the avatar, with the virtual world and virtual learning, we are just at the very beginning tip of learning to use those tools in an application setting for the classroom. And there is a virtual field trip or virtual reality field trip that I wanted to link here to for you from Stanford, so that you can see that avatars, virtual worlds, virtual learning, they are really becoming very manageable for desktop and for classroom teachers. And NGSS does have a lot of statements about technology. So a lot of these statements, engineers not only design new technologies, but they also sometimes fabricate, operate, inspect, and maintain them. And I want to encourage you all to explore digital technologies for simulations. There's a link to those of you who are getting Lenovo's when you go back to work. You go back to school this year. If you're a high school teacher and you're getting a Lenovo, raise your hand. Okay, there are a ton of free apps in this download here called What's Happening by Microsoft Applications Window-Based. So in this download, you'll see applications that are free. There's a heart simulation. There are some planet simulations, and just many tools and apps that we're really going to motivate kids, because simulations simulate what you can't do in real life. Thanks for your patience. That's me. A little later, we're going to go ahead and look at the Jeopardy board. And after you've been reintroduced to some of the NGS concepts, like cross-cutting concepts and the DCIs and all those others, you'll have a chance to earn some Smarties, because we have some Smarties for your prizes today.
Now, some of you have seen this before, and you have gone through this before, but remember there are some folks here and some professors that aren't as familiar with NGSS as others, and some of you have been to many trainings. So we're just going to kind of go through the NGSS component, and we're going to take a look at what's inside your folder also today. So let's just make sure a lot of it is going to be on Canvas, our learning management system. And I think there were just a couple of you that said that you were not able to get into the Canvas. We'll make sure that you are in the Canvas course enrolled, and we will be putting, I know everybody loved Dr. Hansen's PowerPoint. We'll make sure that in Dr. Chandler's PowerPoint, we'll make sure those are loaded up into Canvas. And everything that we do is going to be in Canvas, so that you'll have access to it, especially, if you're not here, you'll be able to go back and see what we did. And if you guys find something really cool that you would like to have us put on Canvas, just send it our way, and we'll put it up on Canvas, because there may be something that we're missing or that you'd like for us to show everyone. So we have a Drive folder, we have a Canvas folder. We're slowly getting everything put up there. Now, of course, live long and prosper. The science standards, the next generation. Now, I was telling someone earlier, not every state has adopted NGSS. It was based from the national standards, but not every state has selected it. I think we've got probably about half of the states have selected NGSS as their science standards. Of course, and some of the states haven't selected the Common Core either. Now, this is where it all came from. This was the K-12 Science Education Framework. This is the national framework. And this is where it came, the NGSS came from, was the framework. You can download, you can buy this book, or you can download this book. So this is good sometimes if you're not clear what the disciplinary core idea, the PE is telling you. You can look into the framework for K-12 education and get a more clear picture. Okay, and most of you know this, but they're connecting nature and science as it's practiced and experienced by real scientists. This isn't just memorizing a bunch of facts. And they build coherently. Like, I've been working with some elementary teachers in National City Elementary and Chula Vista Elementary. I was in a 6th grade class about 2 weeks ago, and they were doing physics. They had little cars, and they weren't doing any calculations, but they were talking about energy, and they were talking about motion. And I know in some kindergarten classes, they're talking about weather, and they're talking about solar heating. So they are doing some science. And I tell you what, they like it a lot better because there's activities that go with it. And it seems to make more sense. And NGSS focuses on deeper understanding of content as well as application of it. And again, they're integrated in K through 12. NGSS is designed to prepare students for college, career, and citizenship. Okay? And again, if you look at a page of the standard, the Common Core for it is also aligned down at the bottom. So if you're wondering what kind of literacy activity could I do, it's there for you. It's all on the bottom of the page. Again, these are some, it wasn't just made up. This is funny. A few years ago, when Anna and myself, Christine, we started doing some NGSS trainings, someone came up to me very mad and said, "I can't believe you thought of this is just too much work for us." Like, what are you talking about? I can't believe you thought of this NGSS stuff. This is crazy. I'm like, I did not think of it. But no, but this is where it came from. It was all my fault. Exactly. Yeah. So again, it came from many different places, and there's also benchmarks for scientific literacy and the Atlas of Science Literacy. So there's our book, the K-12 education book, and you can see the states right there. There's more. Of course, my states, Texas and Oklahoma, no NGSS. They're crazy. Okay, yeah, they're eating Frito pie and not doing the standards. So assessments, curriculum, instruction, and teacher development are all what we need to be successful with our standards. So what is it? Again, I love this quote. You've probably seen this before. Science is not just a body of knowledge that reflects current understanding of the world. It is also a set of practices used to establish, extend, and refine that knowledge. Both elements, knowledge and practice, are essential. And how many practices do we have? 8. Science is both a body of knowledge and a set of practices focused on understanding the natural world. That's why earth science is making a comeback. Yeah! I'm excited about that. Okay, and then moving from current standards to NGSS California standards. Now, you know that California, we love it, it's our state. They have to take a twist on everything. They can't just take the academies and go, here you go. So as we know, California is developing their framework. How many of you have seen the framework? Be honest. Okay, it just came out in draft form. Any day now. Are y'all excited? It's coming out again. 30,000 comments they had were written during the period between January and I think February closed. I know that Pete and I went to an event, and we got to talk to other people from around the county and talk about what was happening. Adrian was there too. What was happening, and we got to put some of our input into this big document that went to the state. And everyone can also have their own input, but 30,000 comments were made. So they're looking at every comment, they're working on it now. Any day now, the framework, the redraft should come out. One more round, we take a look at it, we get to make comments, and hopefully in October it will be finalized. So it's coming. Now, used to, we didn't have any engineering. Super sad. Now, more emphasis on engineering standards and practices that all students should encounter. Little bitty first graders are doing engineering. It's great. Assessing science knowledge. Assessing scientific understanding and reasoning specified by the performance expectations. So we're not just going to be giving a paper pencil test anymore. It's going to be on the computer, and there's going to be 3 parts. And it's probably going to be some drag and drop. It could be similar to gizmos, some type of simulation activity. But it will be all standards. So you're sitting there, so Bobby and Maria are in the same biology class. She may get an earth science test, you may get a physics test. It's all going to be, you never know what you're going to get. It's all together. Limited correlation with other subjects, just like sitting in one class. You're going to have correlation with Common Core, ELA, and mathematics. Limited integration of science disciplines in middle school. Middle school, we're integrated. And do we like it? Yay! Okay. We're working on that. Okay. Tired is allowed. Okay. I think we're getting there. We're getting there. It's been a journey, but I think a year ago there would be no yells. Am I right? There would be only like throwing stuff at the presenter. Okay. I'm just going to put all these up here. So, framing science instruction. Today, now when I say today, I think we are moving toward it. We are moving, Sweetwater is moving over toward the sense-making frame. We're not in, that today's classroom I think is a little bit not quite true about us because I think we're moving that way. But our lesson is centered in information frame, giving information. I know there are times when we still need to give out information, but that shouldn't be the sole purpose of instruction. Lesson is centered on a sense-making frame for instruction. How does it make sense? You're not just giving the kids information. Students are focused on knowing information. Students are focused on understanding. So knowing and understanding, there's some key changes here. Simple things, but key shifts, key changes. Science is portrayed as a body of established facts. Okay, I think Dr. Shapiro was talking about all these facts, but now it's a way to make sense of something. There's still more stuff to learn about biology and to make sense about what you're learning. Both frames are important because, like, again, we do sometimes need to give students we do need to give some information. But research and personal experience show us that most teachers are very good at information frame for instruction. Everyone in here is extremely knowledgeable about science. But sense-making, combining practice with other content areas, with literacy, with math, it's stuff that we're not as familiar with. And making sense. So you all will receive, hopefully, one of these books. They have a spiral on the side. You will get the Science Standards book, and you will get its companion with the appendices. I will remind you, if you want to ask me later what happened to the books, I'll be happy to tell you. But right now, smoke will come out of my ears when I talk about why the books did not get ordered. But we'll talk about that later. Yeah. Purchasing and Melanie do not go together. They see me coming and then, yeah. Okay. It started with San Ysidro High School's chemicals. And Carrie can probably remember that whole story years ago. Y'all's chemicals. Yeah. Your chemicals. All right. 3 dimensions. Now, I don't know if anybody else is wearing orange in here. Anybody have orange on? Anybody have green on? Yay, okay, what is green? Your cross-cutting concepts. Anybody with blue? Yay, what's blue? Science practices. And those are color-coded to help you guys remember, to help us remember which part connects. But what shape is that in? A triangle. It's more than 3 dimensions. It's a Mobius strip. Have y'all ever made one of those with your students? Those are awesome. What is something about a Mobius strip that makes it unique? There's no outside and inside. That's not the... Thank you. That's what I was looking for. It is never ending. It flows together. So, yes, you end up back where you started. So, whoever thought of this Mobius strip, our NGSS writer, thought of this because it has no beginning and it has no end. It's 3-dimensional. All of these 3 go in. You don't just need to know, how many valence electrons the alkaline metals have. You have to know the practices that you can't just know subject. You have to know practices and conduct through which you teach this. Okay? So these are the practices. Now, some of you did get a poster from Anna and myself at the beginning of the year. If you still need a poster, we'll get you another poster for your classroom. So those are the 8 scientific and engineering practices. And those are the cross-cutting concepts. And these are the disciplinary core ideas. This is where your content is. Again, look, it's green, purple, and look at engineering and technology. There it is. It was never there before. It is now. And look at earth science. Ha-ha, it's starting to show up again. It's great. And those are our main LS1, Life Science 1. PS is Physical Science. ETS is Engineering and Technology. ESS, Earth Space Science. And then you put a PS in front of that. HS is High School. And MS. So if you have MS, ESS 1, that's Middle School, Earth and Space Science 1. So those are some ways those are in elementary. Okay? So this is what a performance expectation looks like. Again, you've seen this before. This is middle school, Physical Science 1, Matter and Interactions. And then it tells you what the students need to know. Develop a model to describe matters made of particles too small to be seen. Then below, it's the clarification statements and assessment boundaries, what will not be assessed. There's a practice that goes with PS 1-1, your disciplinary core idea, and your cross-cutting concept. Does that mean you can't use another cross-cutting concept? You have to just use that one? No. You can use another one if you want to. You can bring in something else if you want to. Does one lesson going to teach you everything you need to know? MSPS 1-1. If I do one lesson, can I get everything I need to know about that? Maybe, but maybe not. You want to make sure that you address that whole entire standard when you're creating a lesson. You have a copy of this. This is an oldie but a goodie. An architecture of a standard, just to make sure where everything goes. The connection boxes at the bottom will connect to literacy and will connect to math. And our topics, again, middle and high school, because our grant is middle and high school. And there you go. I know that was something that you guys have seen before, but it never hurts to get a refresher. It always helps trigger something new. But if you're sitting there going, I don't remember a whole lot of that stuff, then maybe that's something you want to brush up on, because some of you are going, oh my gosh, Melanie, why are you doing this? And some of you might be going, I'm not real clear. So again, that's why we're here, is we want to make sure we have a baseline of information for everyone. We're on the same page, and we're moving forward. Now, I'm going to turn over to Odesma because she is an engineer, and I just play one on TV.
Okay, so lunch was so good that I'm really struggling with what we call Macawal syndrome in Trinidad. That's when you begin to feel very sleepy. So I'm going to try to pump it up. Okay, so what is engineering? So I know you had a little experience with it earlier. Some of you already are very familiar. You may have had discussions with your students about it. So I just want you to spend a quick, few seconds, just chat with somebody who's really close with you about what do you see or what do you think engineering is. And then I'm just going to ask a few people to share, and then we're going to move on. Alright, so is there any group or any person who would like to just share their understanding of engineering? Anyone? Yes, and then
identifying a human problem and figuring out a way to solve it.
okay, beautiful. Identifying a human problem, I love that part, and then figuring out a way to solve it. Okay, so the application of physics or applied physics. Anything else? I heard yes, but I didn't see where. Yes.
Creative approach to problem solving.
Okay, so creative approaches to problem solving, so identifying a human need, addressing that, application of physics, and creative problem solving. Yes. Okay, application of chemistry, not just physics. Chemistry, yes. Yes. It could be biology. Let's not forget the life science. Yes? Yes. Okay, so creating a system and being able to apply that system repeatedly over and over again. Yes?
We were talking about designing, solving, improving, and creating systems.
Okay, so designing, improving, solving, and creating systems. Yes. So all of these are all part of what engineering is. Here's just a little woodle that has all these different terms. And I just want to share with you a definition that comes from ABET. So that's our accreditation board that oversees all accredited engineering college programs. And I really like it. It says, engineering is this profession in which the knowledge of mathematical and natural sciences, so all of our sciences, which we gain through study, so it's not just like we're just applying it. You have to study this. You have to practice this. It's something that is gained through experience. And then there is with the application of judgment. So that judgment part is really important because ethics is important, that social responsibility is important. When we begin to apply these concepts, it's not that we aren't doing it or, within a vacuum. We have to understand all the things that are involved. And then it talks about utilizing economically materials and forces of nature for the benefit of mankind. So that's really important here. It's all about improving human life, and it also stresses the fact that our resources are not infinite, and so we always have to think about how we're going to manage these resources in a very economical way. So the exciting part, of course, for me is that engineering is now part of science standards, which means that all students now have that ability to be exposed to what engineering is. So, all of you here are science teachers. So what does that mean? I mean, how is engineering even different from science? Or how is it similar to science? What does it mean in terms of what you've been doing already? Does it mean you have to do something different? Or maybe, are you already doing it? So, let me ask you again, with those who are close to you, just to think about the ways in which you see engineering being similar to science, and the ways in which you see engineering being different to science.
Engineering, the application is all discovery. Once it's discovered, what's more is at school. Manipulating the world around the scientists.
Is there a middle ground? Or is there no middle ground?
That's why I think that doctors exist. Engineering things, medicine exist.
So I'm hearing a lot of really good conversation around these things. So I'm just going to ask if you can share some of the things that you've already discussed. So how do you see it being similar? Anyone? Yes. Okay, so they both sort of follow a very systematic step or process. Yes. Yes.
Our best focus is to be able to teach them the problem solving. Whether they're using practical things that they would find in real life or whether they're using more theoretical information.
So both science and engineering problem solving is common to both. Yes. What else?
They both try and answer like a question and a problem.
Okay, so they both are addressing a question or a problem. Are the questions or problems the same, do you think, or are they different? Okay, they might be slightly different, okay. What else might be similar? Yeah, sure, please.
They both work in teams.
Okay, so teamwork is a big part of the real practice of science and engineering. So both contain problem solving, both follow a sequence of steps, so you require that disciplined process. Both may require team or collaboration. Yes.
They're both typically mathematical.
Okay, so both of them may utilize mathematical modeling, possibly. Data, so they sort of decision making, or you are deriving things from a data perspective, yes?
They're both like additive to a large base of knowledge.
They're both additive to a large base of knowledge, yes? by no means is this an exhaustive list. So developing and using models, we can see that both happening in science and engineering, planning and carrying out investigations, analyzing and interpreting data, and then moving forward from that understanding. The use of mathematics or computational thinking, engaging in this evidence-based argumentation, that's a big thing, obtaining, evaluating, and communicating information. And of course, we have this process that you repeat over and over again. I mean, you have to replicate in a science experiment. And there is this sort of iterative nature of the engineering design process. And again, I do want to clarify, when we talk about engineering in NGSS, we're really talking about engineering design. So there is another aspect of engineering that's not part of NGSS, but what we're really talking about is the similarities between sort of that scientific process and engineering design. Now, how are they different? Yes?
Science can be kind of more theoretical and esoteric, but engineering is tend to be more practical, concrete to solve an actual issue.
Okay, so we can tend to have science where you're looking at more basic concepts of understanding.
Like black holes, you know, people are talking about things that are, I don't know how you put them. It's abstract. You know,
Okay, a little abstract.
Versus like, okay, now we need to solve a rock issue, so that's would be more looking at aqueducts, especially concrete, and more tangible.
Okay, so we're looking at abstract versus concrete, or more tangible. Other different, yes?
Well, thanks to technology, our engineering can go faster, we can reach farther. There's so many things that with our own senses we cannot reach so easily.
So you're saying with engineering you can go further or faster, you can make advances faster?
Yeah.
Is that
Like,
okay?
for example, computers.
Uh-huh.
I mean, a computer can make the job for that would take us days or weeks in a few seconds.
So you're saying engineering creates the technology that may help make things go, advancing the science further?
Yes.
Okay. Okay, I like that. Yes.
In science, there tends to be sort of this reductionist view, where you're really concentrating on one and focusing on one area, whereas engineering oftentimes takes a lot of different disciplines into consideration.
Okay, so it's more multidisciplinary sometimes, depending on the type of problem. Okay. Yes. The end goal is different. What way? Okay, I love that. So in science, the end goal here might be to answer a question, whereas in engineering, we might be trying to solve a problem or address a need. So we can, again, as you rightly said, with beginning, in terms of science may begin with a question about why or what, why is the sky blue, what causes cancer, about the black hole concept as you mentioned. Whereas engineering, talking about that sort of abstract versus more concrete here, we have a problem, a need, or a desire that we're trying to address. Both involve questions, but maybe the way that we ask those questions. So science, where we're having these empirically answerable to guide our study. And in engineering, we may be asking those questions to help us further define the problem that we're trying to address or the need that we're addressing. Both involve data. In the sciences here, we're using that data to help analyze or to derive meaning. With engineering, and again, engineering design here, we may be analyzing that data to compare different possible solutions. And the goal here, knowledge or theory to explain something, as you mentioned. So the goal with the science might be to help us understand or develop more knowledge about a concept. Whereas with engineering, we're trying to address that need or problem that someone has identified. So we could kind of look at that scientific inquiry where we begin with this physical system or the object of study. We make measurements, come up with this concrete description through that data that we gather. And then through some comparison, there's a sort of an abstract model or theory to help us understand that phenomenon. And we can actually think of engineering then, again, starting from that particular point where we start with that abstract model or design concept, and then we're coming up with a concrete description or specification, and now to produce a physical system or useful product to address a need. So we can almost see it as a continuum. So why add engineering to the science mix? So there's one train of thought that says by incorporating engineering and design and technology, what we're doing is we're allowing students to now apply their science understanding to solve problems that are practical and relevant and important to their daily lives. And kind of going back to what I had mentioned earlier, this is really where I begin to see that social justice becoming part of our science, because now we're beginning to show students that you can now take this knowledge and apply it to things that are relevant to you, to your community, and not just what somebody else thinks that is important to you. So it's really empowering students and sort of giving them those tools that they can now make a difference, whatever that may mean for them. And of course, we are living in a very technological world. So I think, in terms of the role that science is going to continue to play and engineering and technology, we need to ensure that our students are equipped and ready to embrace that their world, that's going to be their world. I mean, their future in a way depends upon it. So it's to us to ensure that we're giving them the tools to be able to really empower them so that they can really set that course and chart that course. So we talked about the engineering design process because that's really the focus of what NGSS has in terms of the engineering design aspect. And so if we kind of think about the way we may have done a traditional type of science lab experience, where students, they have learned some certain concepts about different chemical reactions or properties, and now you provide them with a list of materials, and they're giving sort of a lab procedure, and they follow those things to a T. And the goal here is that they must at the end come up with this. In this case, it could be white soap, if that's what the objective was. But they really are sort of that very cookie cutter, sort of just following step by step. And if we begin to think about how we can add an engineering sort of approach or engineering design approach to it, in this case, we're giving them this real-life scenario where you might want to create purified water in a particular environment. And now they have to apply their understanding about all the concepts that come into play in terms of filtration or purification, etc. And now they have to look at what are the tools that are already available to me and begin to make those connections, putting things together, and coming up with a solution that works given the constraints that they have. So similar but yet very different in terms of the approach and how they are empowered to apply that knowledge. With that, thank you.